Okay, let's get into it. Today, we're doing a deep dive on a topic that's really critical but often overlooked: professional video connectivity.
Hmm.
We're looking at the tvONE line of cables and adapters, using some reviews from HDTV Supply as our starting point.
Right. And this is a fascinating area.
It is, and our mission here is really for you to understand what it takes to get a perfect signal from point A to point B, especially when the stakes are high. What's the difference between a cable for your TV and one for a live broadcast?
Well, the simple answer is that tvONE isn't really in the consumer gadget business. They specialize in professional video processing signal distribution.
Okay.
So, their products are built for environments where failure is not an option. Think broadcast studios,
Okay.
huge corporate events, universities. Zero tolerance for error.
But wait, help me understand something. My 4K cable at home seems to work just fine. Where's the invisible failure point that these professional lines are designed to solve?
It's all about signal integrity, especially over distance and time. The goal they state is maximum clarity and fidelity with minimal interference.
Okay.
So a standard copper cable, the longer it gets, the more the signal degrades. It's called attenuation. You get voltage drops, changes in impedance.
And that causes, what, glitches?
Exactly. A flicker, a dropped frame. In your living room, that's annoying.
Yeah.
In a live production environment, that could cost millions. These cables are engineered to make sure that just doesn't happen.
So signal purity is locked down.
Right.
What about connecting things that shouldn't connect, all the different formats?
Yeah, that's where the adapters come in. And they have to support everything: HDMI, DVI, DisplayPort, even old school VGA.
Right.
It's like they act as a high-speed universal translator. Imagine you have a brand new laptop with an HDMI output,
Okay.
but the projector in the auditorium is ancient and only has a VGA input. That adapter isn't just a simple plug. It has to actively convert a pure digital signal into an analog one. Perfectly.
So it's doing complex work inside that little box.
A ton of work. And doing it reliably every single time is where it gets tricky.
All right. This is where I think engineering just becomes, well, mind-boggling. Let's talk about distance. Sending a perfect HD signal across, say, an entire event hall. Copper's not going to cut it, right?
Not even close. For high bandwidth HDMI, copper really starts to fail reliably after about 50 feet. It just quits.
So what's the solution?
This is where we get into their active optical cables,
Right.
or AOCs. They make them for HDMI 2.0, DisplayPort 1.4.
Active optical, so light.
Exactly. The active part means there are chips in the connectors at each end. They take the electrical video signal, convert it into pulses of light, send it down a fiber optic strand inside the cable, and then convert it back to an electrical signal on the other side.
Wow. So it's not really a copper cable at all in the middle.
Right. And light doesn't suffer from that same kind of signal loss over distance.
And the distances they can cover are pretty stunning.
Oh, yeah. They start at around 33 feet, which is 10 meters, and go all the way up to 328 feet.
100 meters.
100 meters.
Yeah. That's incredible. That really shows how specialized this is.
And that specialization comes with a price tag to match. That 328-foot HDMI 2.0 cable, for instance, is listed at $945.
Wow. $945.
Yeah. But you're not paying for the material. You're paying for the guarantee. The promise that the signal will be perfect when failure could mean a complete operational shutdown.
So let's bring this all together. What does this mean for you, our listener? Even if you don't need a $1,000, 100-meter cable, understanding why something like an AOC even has to exist shows you just how complex high-definition video has become. To maintain that perfect digital signal, we have to move beyond electricity and use light itself.
It's a fundamental shift in the technology.
It really is. And it leaves me with a final thought for you to chew on. If we already need to use light to send a flawless signal just 100 meters, what other fundamental physical limits are we going to run into as video resolutions keep climbing to 16K and even beyond?